This is a router lift by Jessam, Craig and Woodpecker, and they cost $400+. But what if I could just 3D print it? I have 3D printed some functional tools before, like this one. These are not mechanical and they don't have moving parts, but I believe with some hardware it could be done. But is it possible to design a router lift as good as a commercial one? Let's first understand what is a router lift and what do we need to build one. After setting up your router in a table, you will have to go under the table to change the bits and their heights. That's what you use a router lift for. You can do those operations without crawling under the table. Looking at the commercial ones, we can see three main parts in it. Top plate, which has to be rigid, some cylindrical guides. By the way, do they really have to be cylindrical? And of course a mechanism to lift the router up. Manufacturers usually do not share their blueprints and especially 3D printable versions. But lucky for me, I happen to live nearby the guy from USSA. Открываем, пришли. Роутер.
Туго идет, потому что подшипники зажаты.
Это для пионеров. Одиссея концепт.
Той самый первый. And I think he has an obsession with routers, and he has built several router lifts and jigs in the past. As of today, there is a router 3.0 available on the website. But being his neighbor and a friend back from university times, which makes me a little biased, I had an access to yet unpublished versions. And during the shooting of this video, there's been back and forth how to make it a better router lift. So that should remove the bias. I wasn't gonna publish a video about a product that I personally wouldn't buy. So, the three main questions are: is it easy to build? Is it really affordable? And can it actually be better than those on the market? Let's first find out if it's easy to build it. We begin by 3D printing all the components. You can see me using a new printer that I've got. I'll probably make a separate video about it, but for now I can just say it's fast. And it obviously needs some tweaking for better results. It's not ready to use out of the box. These following clips are not sped up. That's how ridiculously fast it is. Which of course comes at a price. You'll probably notice it later on. And also, prints do not stick without the glue applied, so you always have to apply glue. Everything is printed, and you can see just how many of different parts there are. There are even some TPU parts, which is super fun to play with. Once I gather everything together, you get a real sense of how large this tool is. But in case you don't have a printer and do not want to learn this skill, you could just use the sponsor of today's video, PCBWay. They're experts not only in 3D printing, but also CNC milling and PCBs. They work with advanced machines and materials, like SLS printing. In case you're working in one of these fields, they provide all the necessary services when you're prototyping and need the top tier finishes, advanced materials, and overall quality for your prototypes. Links are in the description. Back to the router lift. I will use this untouched tabletop of my modular workbench to house a router lift. One of those prints was this milling guide. It has to be from 4 parts, otherwise it won't fit on a 3D printer bed. This process will be a 2-part job. First, I will stick these 4 corner pieces, and then we'll mill through the whole thickness of the tabletop. By the way, this jig is from the same brand. Its extensions make it much easier to mill through, because the router stays on the same level throughout the whole process. And of course, there's the vacuum hose, which I find to be the most annoying part of milling. I just wish someone would make a jig with a rotating router. We remove those pieces and mill just 12 mm deep. The remaining thickness is going to be a bedding for the top plate. Okay, now don't ask me why, but I decided to build a little Manhattan on my table. These are all the things required to build this router lift. We are adding thread inserts to these prints. And there are a couple of reasons I prefer wood thread inserts over heat inserts. First, wood thread inserts are reusable. You can unscrew them anytime. while heat inserts are more difficult to remove. Second, they are faster to install. These two blocks are for holding the router in place after we set the height. Because of the smaller diameter, we'll need to use the heat inserts here. I know two methods for installing them. One involves a soldering tool, but I prefer to do it the way I'm showing you here. The next part is going to house a lifting mechanism. After we're done with it, we deal with the chunky one. To reinforce an overall structure, we add two M6 bolts on each side. Next up is this long nut, which is a part of a lifting mechanism. Also, I have forgotten to add these side inserts on two previous blocks. Like I said before, that printer is too fast and it comes at a price. Two M4 and one M6 inserts go on this side, and 8 M8 on the other side. They are heated a little longer, but also really easy to install. They will be used for adjusting the top plate on a table. If you screw them in deep enough, they will start raising the plate. These two M4 bolts will fix different diameter plates for different bits. The following process doesn't really need narration to understand. So let me quickly explain the name of this tool, the Odyssey. The journey to create this router lift has been long and full of twists. It all started almost 4 years ago with USSA's dream of building a router lift that was more affordable and accessible for beginners. From personal experience, he found most router lifts were bulky and priced over $400, which made them out of reach for many people just starting out. USSA wanted to change that. As he worked on router lift 1, 2 and 3.0, he discovered an enclosed vacuum lift system, which introduced a second goal, adding dust collection to the final design. But as the design progressed, he realized it was still too complex for a first manufactured tool. So he decided to launch a simpler tool, a trim router jig. And after a successful project, USSA decided to revisit the router lift idea. However, realizing that it's still almost impossible to achieve a lower price point, he decides to design a simplified version using 3D printing in manufacturing. More on that later. It's almost ready at this point, and after a little test, we can see this happening. In order to prevent it, we add this ring at the lowest point our router should go. These two knobs are required for the fixators to work. They push in an inner detail, which creates a friction that prevents a router from moving. Okay, now it's finally done and we need to install it. Those 5mm that are left after milling 12mm are not enough. That's why we use these accessories. We check the fit and adjust those M8s to level a plate with the table. We take it out and it's finally time to put a router in. The lifting mechanism works smoothly, and I can easily change the router bit from the top of the table without crawling underneath. This is the real beauty of the router lift. Convenience. After making a few final adjustments, we're ready for testing. If possible, you should always use this part, but depending on your task, you might need to remove it. As we can see, even without it, there is almost no dust. I personally am a little skeptical on using a plastic router lift overall, and especially this top plate. If you're just like me, here is a solution to that and something that levels up the overall experience with this tool. An aluminum top plate. Back to the story. So he ended up with two different designs. In-house manufactured one that is not suitable for 3D printing and should be done from metal, with potentially patent tech. And the other one, specifically designed for 3D printing manufacturing. Now it has two versions, the more professional one, metal build, and 3D printed ROM for beginners. With both models, USSA was able to achieve the original goal of an affordable router lift, with the added bonus of dust collection. The name Odyssey reflects the long and winding journey of design and development that ultimately brought this tool to life. Okay, back to the router. We level it to the table again, and the tip is to use a ruler. Dust collection is essential for small workshops, And it's something that sets this lift apart from most commercial options. It works almost perfectly, judge it by yourself. And I cannot stress this enough, how important it is in a tiny workshop. To answer the first question, and it's probably an obvious answer by now, it's not that easy to build. And here is the solution to that. The one that I've just built is gonna be manufactured by USA himself, and mostly from aluminum. But he also designed a much simpler version, a 3D printable one. Here it is, much less components overall and especially hardware. You can see how easy it is to set it up, and you should be familiar with all the parts by now. I would just point out that the guides do not have to be cylindrical after all. They don't even have to be from metal. To answer the second question, I think it's super affordable. If nothing changes, the price for 3D model is gonna be $40, plus an additional $80 for a metal top plate, and around $270 for the mostly aluminum version. But in case you don't want to deal with printing and assembly, you could order an already assembled version with aluminum top plate, and it's gonna be cheaper for about $100 than this one. And now to answer the main question, is it better than commercial ones? It has a deal breaker feature that's not to be found on any other outer lift, dust collection. Just look how effective it is. Thick aluminum plate and robust guides leave an impression of a rigid tool. The lifting mechanism here works okay, but also promises to make it flawless. And bear in mind, this is a prototype. Of course details are gonna be added, and surfaces are gonna be finished. Another standout feature is its compatibility for different routers. For 3D printable version, you'll have different variations of this part. For example, I have Milwaukee and DeWalt routers, and you can see how different these two are. To conclude, I, the person who works in a small workshop, personally think it's better than the commercial ones for two reasons: the compactness, plus an ability to become a plain surface, and dust collection, which is super important for tiny spaces. So there you have it. To pre-order this little wonder, you can find the link below. But if your main work with routers is done above the table, you should check out this pinned video about another product by USA, which is in stock.